Hello people, welcome back to the corgi64 project. Last time we actually created some branch operations. Let's see if we go over to our CPU. Created some jump opcodes, the unconditional jump and the branch on equality. And what we're going to work on today is a few more of these branch instructions. We're going to get, let's see, we're going to see if we can do the branch if not, if the zero flag is not set, and branch for greater than and less than. I think we'll be able to do that. So let's go ahead and go to our cpu.h file, and we'll go ahead and copy our branch on equal. And let's see, the next one that we're going to do, we'll do a branch if not zero, right? So that should be pretty easy. So BNZ. So we're going to branch if we're not zero. So if this flag is not set, then we will jump to that instruction value. We can also go and create a test for this. So we'll do a test, B and Z, and we can say the instruction value. Let's see, flags. We want to say if it's not set, so we'll say okay, that, and then we'll give this a different number so that when we print it out it looks a little bit better. It should see 15 on the other side. And then what we'll have is we need to actually run this test. Run the test B and Z with the CPU. Okay, and that should be good enough to actually go and test. So let's go do that. Let's do a build test. Looks like that passed. So if we do bin test.exe, oh, looks like we actually had a little bit of a problem. Assertion failed. The program counter is not 15 like we thought it would. Did I set up the test correctly? Let's see. So the instruction value is 15. Oh, did I set the flag correctly? Let's see. So what we want to do is we want to get this the 0th bit, and we want to check if it's not equal. If it's not equal to 1, if it's not set. Actually, what we really want to do is we always want to check for equality for this. So we'll actually check, see if it's equal to 0. That way it'll tell us this first bit. Remember back with our CPU design, the first bit says whether we've got a 0 flag, right? So if it's set, then we know it's 0. If it's not set, we know it's not 0. So if we go back to our thing, we're going to say, okay, actually, if we go back to our test, we're going to say, okay, we're going to make it 0, so the 0 flag is actually not set. And then it should, because it's not 0, right? Let's see, that's what we're looking for. B and Z, branch if the negative flag, let's see, oh, do I have a negative flag? Oh, branch if the negative flag is set. BQ is branch if 0 flag, branch if not 0, if 0 flag not set. Okay, yeah, so we're doing this correctly. So let's see, we've got test. So the test, we've got our flags. That's set to 0, so we should be okay. Let's see if we can build and run. No, we've still got a problem. Our assertion failed on our program counter. So why is that? So our program counter equals 5. Instruction value, test B and Z. So did we do something incorrectly here? So we're getting this 0th flag. So we're getting the 0 flag. We're checking if it's 0. If it is, we set the program counter to the instruction value. So what are we doing incorrectly here? Let's do a printf, and we'll give the C instruction value, and we'll get, what is this, a long double maybe. Or a long integer. Let's see. So copy. Let's see what happens when we build and run. Okay, so what do we get here? Oh, did I just give it the wrong name? Let's see. That may be B and Z. Oh yeah, you know what? Let's take a look at our tests here. Let's go to our tests. Test B and Z. Did I call the... Nope, I called BEQ. So let's call B and Z. That should be much better. So we'll build our test, we'll run our test, and it passes. So we've got that 15 that came out of our program counter at the end. So all I did is I just messed up the name here. I needed to call the right opcode. So that's cool. So let's go back over here, and before we forget, let's put the opcode in the right place in the opcode table. So the B and Z is 25 hex. So let's do that. So 2, or 2, 5. There we go. B and Z. That gives us that. And then we also want to do in 2, 5. We want to 2, 5. We actually want to make this a 9 as well because we have an address that we're wanting to jump to. So that fixes that up. So now that I've got that out of the way, or now that I know how that works, let's see, we did BEQ, B and Z. Now let's branch if the negative flag is not set, so we know that we've got a greater than. We can do that real quick. Let's see. And was that BGT? Is that what we called it? Yes, it's called BGT, and the other one is BLZ. So we'll do BGT, and we want to get the greater than one, so we want to get this first bit, and if it's not set, then we will set the instruction value, and then we'll go to our tests, and we'll do BGT, and we'll set this to some number. We'll say 12, and the PC starts out at 5, and we'll remember this time to do BGT, so we'll set that up, and then we'll actually run this test. Our test list is getting pretty long. Okay, so that tests our BGT. Let's build and run. So what did I do incorrectly? Oh, I didn't set up the test correctly, right? So we need to search for 12. Right, so let's build and run, and now we've got 12. That's good. So we're moving along pretty quickly here. And the next thing that we want to do is the BLZ, branch if the negative flag is set. So we'll do that. Let's see, branch if the negative flag is set. And this is BLZ because we're going for less than 0. And the flag will be set if this is actually a 2. And maybe what I should do for this is maybe it would be more readable if no, actually this returns the flag itself. I was thinking for a second that maybe I should have like a 1 and move it over, but no, we've already got we're already grabbing this value, and it will either be a 0 or 1. So we don't have to worry about that. We just only have to compare with 0 or 1 once we get the flag that we want. So let's go back over to our tests and create our BLZ test. Actually, okay, let's grab this. And this will be our BLZ test. And we're going to call BLZ. And then let's see, let's go and we'll make this a different number. We'll say make it 17 or something like that, and we'll make sure our test is correct. We're going to test for 17. Then we'll go test BLZ, give it our CPU, and now we should be able to run our tests. What did I do wrong this time? Let's see, failed. So it's not 17 like I said it was. Test BLZ, so I gave it BLZ here. We have a 17 there, we have a 17 there. Did I... oh, you know what? I need to set this flag. I need to set the proper flag. So this one is basically, remember this is equivalent to 1 being moved over by 1, you know, or let's see, 1, 2, 3, 4, 5, 6, 7, 8, right? Having this, whoops, 1, 2, 3, 4, 5, 6, 7, 8, right? So we're setting this flag, right? So in that byte, in this first byte, we're setting the 1 flag, so that's the equivalent of a 2. So let's go ahead and do that. So it should work now if we build and run. Yep, it runs. So we've got that 17 for the PC. That is pretty good. So I think what we're going to do now, let's see. So actually what we're going to do is we're going to cancel these, this for now. We're not going to have an overflow flag and underflow flag right now. So these, we actually may remove these altogether and replace them with something else. Let's see, do we already have, oh, the other thing that we should do is before we forget, we should put this BLZ in our op table. I believe it should be 2.6. So if we go 2.6, or let's see, actually, where is BLZ? 2.7? Yeah, 2.7 is where we should be. So if we go to 2.7, does that mean I messed up on my other ones? So 2.7, this should be BLZ. And that, does that mean I messed up on my BEQ and BNZ? So BEQ is 2.4, so that one is probably correct. And BGT is 2.6, right? So yeah, I was off by 1 there. So let's put that back to no op and BGT. That will do that. And so then we need to actually go do, what did I do here? So 5's not set yet, but 6 will be a 9. And 7 will be a 9. So that's pretty good. So I think we've got that. So eventually we'll end up testing these op tables as well. And I think that will actually be pretty good for now. Let's see, next time maybe we should implement some of these bitwise operators. We're getting pretty close here. So yeah, maybe we'll look at the bitwise operators or maybe some of these interrupts. But thank you very much for watching. Till next time.